Number 8. এটা কি দেখতে উইয়ার্ড দেখে জিজ্ঞেস করতেছে নাকি পারো নাই? কে করে এটা করতে গিয়ে? আচ্ছা দেখি। Okay, so state what's meant by gravitational force. So what is the answer? What's gravitational force? What's gravitational force? Right, mass, object now. So what is meant by gravitational force? It is the force experience exerted now. It is the force experienced by a mass. It is the force experienced by a mass in a gravitational field. No, gravitational force is experienced by any mass. Point mass কখন লিখতে হয়? Point mass লিখতে হয় when you're describing something that's actually a derivation of an equation. So for equation purposes, we assume them to be what masses? Point masses, but they're not really point masses. So এখানে বলছে a binary star system consists of two stars, S1 and S2, each in a circular orbit shown. The orbit of each star is in a system that has a time period of oscillation t. Observations of the binary star from Earth are represented here. So binary star system observation to dawa ekhane, so it's oscillating. Kemne oscillate korteche? So you have one star here and the other star there. We talked about binary star systems the other day, so it's something that's possible in your syllabus because the math is not really complicated. Right, so this is a binary star system. Binary star system হচ্ছে oscillation টা এরকম হয়. Let me try to yeah, so it's going to be like this. Rotate হতে থাকবে. So that's like a binary star system. They're rotating around the common what? Center. Okay, so your T/4 এর মধ্যে it goes there, তারপর T/2 তে it goes there, T/3, then it goes back to normal again. It says that observed from Earth, the angular separation of S1 and S2 is 1.2 radian. The distance between the binary star and the Earth is given. Show that the separation d from the center S1 to S2 is attometer. Right? A question ta jodi bujho, it's actually pretty straightforward. I'll explain. So কি বলছে? It's a very random question, by the way. মানে it's not usually a thing that তোমাকে জিজ্ঞেস করে. So এখানে বলছে observe from Earth the angular separation in the centers of S1 and S2 is 1.2 into 10 to the power minus 5 radian. The distance of the binary system from Earth is given here. Show that the separation d of the center S1 and S2 is given by excuse me, that value there. So কি আমাকে একটু বলতে পারবো কি মিন করছে? Is there anyone who can answer this? Like for the angle is taken from where? Very good, right? So from Earth, if you take this, the angle between the two seen from Earth is 1.2 into 10 to the power minus 5. Is that what you meant? Yes, correct. And it says a distance of the binary system from the Earth is 1.5 into 10 to the power 17 meters. Which one is that? One of the radius. Yes, correct. So you could take one of the radius, you could take actually the center as well. Doesn't really matter because the distance is what? Extremely far away. So it wouldn't really have a consequence of your answer. So it also 1.5 into 10 to the power 17. তোমাদেরকে বের করতে হবে কোনটা? এই যে that. So you can assume this to be part of an arc length. And তোমাদের arc length এর formula তে জানতে হবে. In fact, there's a very strange definition in your syllabus. What's a radian? What's a radian? Right, yeah, if it's the angle is less than 5 degrees, then the thing becomes a rectangle, like a triangle, right angle triangle. So we can just use r s equals to r theta. তোমরা কি এই ফর্মুলাটা শিখো, s equals to r theta? Okay, so if I want to find the arc length here, S should be equal to radius is going to be what? 1.5 into 10 to the power 17 into theta jeta ekhane, the theta has to be in radians. How do you find theta? Yeah, directly dawa ase, okay? So 1.2 into 10 to the power minus 5. Sometimes they'll give you degrees. Degrees jeta korte hobe theta by 360 into pi, right? So you have to convert it in radian. So yeah, koto ashe? Sorry? It is an arc. It's so far away that the arc appears to be what to you, right? But it's an arc, right? It's a radius. Sorry? Oh, you can try that. করে দেখো কি আসে। না আমি জানি না। তুমি করে দেখো কি আসে। You'll see. It'll answer your question for you. Do you know কি আসবে answer? If you take this as a triangle, same. Because it's less than 5 degrees. 5 degrees এর কম থাকলে sine এর যে ফর্মুলাটা আর triangle এর যে ফর্মুলা, they both have the same outcome. কত আসে এটা? এটা কি সেম ভ্যালু আসে? 1.8 into 10 to the power 12. Okay, 1.8 into 10 to the power 12 meters. Alright, যারা অনলাইনে জয়েন করছো, আমি হচ্ছে question number 8 করতেছি। Okay, the stars S1 and S2 rotate with the same angular velocity omega about a point P as illustrated here. Point P has a distance of x and everything given here. Calculate the angular velocity omega. Omega equals to 2 pi by t. এখানে হচ্ছে টাইম পিরিয়ড দিয়ে দিচ্ছে, টাইম অফ রোটেশন, সো 2 pi ডিভাইড বাই টাইমটা হচ্ছে 44 years, right? So 44.2 into 365 into 24 into 3600. Can somebody check what the value is? 4.5 into 10 to the power minus 9 rad per second. So 4.5 into 10 to the power minus 9. By considering the forces acting on two stars, show that the ratio of the masses of the star is given by this. Yes, now একটা জিনিস হচ্ছে clarify করি, এখানে হচ্ছে the system is undergoing circular motion, right? And what is responsible for the circular motion here? What's providing your centripetal force? Right, the gravitational force of this by that, and the gravitational force of that by this. And you should know by now they're what? Same. Can know they're same? Because it's a mutual force. It can be impossible. Find out one big mass applies small force on a smaller mass, and a smaller one applies the bigger force on the larger mass. They apply what force on each other? Same. You are applying the exact same force on the earth right now as the earth is applying how much on you? Same. Okay, so earth ja apply kore tumi same tay apply kore. There's nothing different to it. It's called a mutual force. F equals to gmm by r squared. Eta যায়. So এখানে আমাদের এই ফোর্সটা towards this point যা হওয়ার কথা, এই ফোর্সটা towards that point কি হওয়ার কথা? Same. So এখানে ফোর্সটা কি হবে? F equals to g. এখানে আমাদেরকে কি বের করতে বলছে? ডিসটেন্সটা, right? So ratio of mass. So S1 m S1 times কি হবে? ms2 divided by what's this distance? X squared. আর ওটার জন্য কি হবে? F equals to g ms1 ms2 divided by distance into different হবে, কি হবে? D minus x whole square. Is that okay? D minus x whole square. হ্যাঁ, সো এখন আমাদেরকে কি করতে হবে? এখানে রেশিও করতে হবে। রেশিও করলে কি সব ম্যাথ ক্যান্সেল আউট হয়ে যায়? না বুঝছি, এটা ফিল্ড স্ট্রেন্থে করবো আমরা। Yeah, that'll be actually easier. কারণ এখানে তো ফোর্স এমনি ক্যান্সেল হয়ে যাচ্ছে। So we do it this way. Centripetal force of S1 should be equal to centripetal force of S2. Centripetal force হচ্ছে m omega square r, and this is going to be m omega square এটা r1 and m omega square r2. Omegas are same. So because same time period নিচ্ছে নাকি? Same না? Rotation, yeah, it's a central system. So omega and omega cancels out. M is going to be m S1 R1 equals to m S2 R2. So আমার হচ্ছে S1 by m S2, কয় মার্ক এটা? 2 marks, right? So equals to R2 by R1. R2 হচ্ছে D minus X and R1 হচ্ছে X shown. Previous to the previous to the কারণে হয় না হচ্ছে because the constants are the same. So just length ratio beta, bakita beta. This part is important. The mass m1 of star s1 is given by the expression this, where g is the gravitational constant. The ratio in 2, a ratio is found to be 1.5. মানে হচ্ছে তোমার this is equal to 3/2. And use the data from B and your answer in CI to determine the mass of M1. Data from B. B তে কি data ছিল? দাঁড়াও, B টা দেখে নি। B টা হচ্ছে ওরা বলছে the separation is 1.8 in 10 to the power 12. হ্যাঁ, বলো কি বলতে চাচ্ছিল? হ্যাঁ, এই যে এখানে বসাই দেবো। হ্যাঁ, right. So এখানে হচ্ছে the separation here between the two masses is D, and D কত আসে? 1.8 into 10 to the power minus 12. So আমার 12 meters. আমার দরকার কোনটা? আমার দরকার x. So first আমাকে x বের করতে হবে. How do you find x? 1.8 into 10 to the power 12 minus x divided by x equals to how much? 3/2. এখান থেকে x এর ভ্যালু আসবে। কেউ যদি করে থাকে আমাকে বলতে পারো। 10 to the power 11. বলো কি প্রবলেম? I can help. Two variables in your equation. Acha. So yeah, you have x as a distance. So x চলে আসলো। আমার বের করতে হবে কি? M1. So I know x, I know d, I know d, I know omega, I know g. So I think just সবগুলো বসালে হয়ে যাবে, আর কিছু এরকম নাই। So g is 6.67 into 10 to the power minus 11 into m1 equals to d squared. D হচ্ছে 1.8 into 10 to the power 12 squared into 1.8 into 10 to the power 12 minus 6.4 into 10 to the power 11 into omega square. Omega is going to be that thing that we saw here. 8 and omega. 7.2. X এর ভ্যালু কি কেউ বের করছে? আচ্ছা হ্যাঁ, অনলাইনে একজন বলছে it's not 6.4, it's 7.2. So yeah, once you put them into your equation, you should get the value for M1. M1 কত আসে? How much is M1? হ্যাঁ, মনে হয় 2.4 into 10 to the power 38 kilograms. Then we had অনেকে বলছে তার আগে 4 এ একটা প্রবলেম ছিল। 4 এর প্রবলেমটা দেখে আসি। 4 কোনটা ছিল? 4 2 3 4 4B3 again. আচ্ছা হ্যাঁ, এই 4B3 টা হচ্ছে একটু ক্লারিফাই করি। কোশ্চেনটা কি ছিল আমি একটু আগে বলি। So we have done this before, circular motion, not in gravitational field. Gravitational field or question this. So you have the earth here, and there's a weighing machine, on the equator of the Earth, and there's also a weighing machine on the pole of the Earth, North Pole, let's say. Now the Earth is spinning, and the Earth spins, let's say, that way, that way, that way. These are the spins of the Earth. Now, if you look at the weighing machine that's at the pole of the Earth, right? It is actually not undergoing circular motion. Why? If yeah, so ফ্যানের একদম center যেটা, if you think of that point, right, it's actually not undergoing circular motion. You can put your finger there. It's just rotating, not circulating. And it's not going in a circle. It actually just goes ঘুরতেছে. For you to have circular motion, খুব important, you need to have what? Radius. You have to be away from the center. You can't be at the center. Okay, so এখানে হচ্ছে যে থাকে সে কিন্তু on the center of the circle. Or radius কি এখানে? 0. How much centripetal force is needed for this person to stay there? F equals to m omega square r. এখানে radius যেহেতু 0, centripetal force কি লাগবে? 0. So for whatever reason, let's say Earth's gravitational force disappears, right? And it's not there to keep you in its orbit anymore. There's only one place where you can be and still stay on Earth. কোথায়? The pole. কারণ ওই পোলে থাকলে you'll just hang in there. কোনো কিছু হবে না. The Earth is not needed to keep you in its orbit. But সবচেয়ে বেশি effort Earthকে দিতে হয় কখন? When you're at the equator. Why is that so? Because right, so the radius is the biggest here, and because the radius is the biggest here, what happens is you have the greatest force needed, right? So in this case, how do you find this force? So F equals to m omega square r. And এটা করে আমরা যেটা বের করি, let's say এই কোশ্চেনের এক্সাম্পলটা দেখাই তোমাদেরকে. The centripetal force that we got here was 3.73 kilograms. মানে লাগবে না কত? 3.73 না, 0.017 Newton দরকার. This is the force that's needed to keep you in the orbit. However, there's a small issue out there, which is when you stand on an electronic balance or a weighing machine, right? It never shows your weight. What does it show you? The reaction force, right? And reaction force যেটা পাচ্ছ এখানে, it's actually what's left after the weight has been used up. Let me explain. So তোমার নিচের দিকে weight আর উপরের দিকে কি force? Reaction force. Typically speaking, what are these two forces? Equal. And that's the problem, কেন? For circular motion to take place, you need to have a what force acting towards the center? A resultant force, a centripetal force, but a resultant force, right? W or R যদি equal হয়, there's no resultant force on you. How can you create a resultant force here downwards? There are two ways. একটা হচ্ছে weight কে বাড়ায় দেওয়া, which you can't, right? আরেকটা হচ্ছে কি কমায় দেওয়া? Reaction, right? Reaction যদি কমায় দেয় তাহলে resultant force, মানে I need a net force acting downwards. Simple words, okay? What has to be the outcome here? W has to be what than R? Greater. And W can be greater than R in two ways. W itself increases or R decreases. W to change করার কোনো scope নাই. It's the gravity out there. So eventually W minus R should be your centripetal force. Therefore, R should be equal to what? W minus FC. So once you stand on the balance, তুমি যে force experience করবা is actually just R. And এই R টা হচ্ছে দেখা যাবে কম because এখান থেকে কি minus হয়ে যাচ্ছে, the centripetal force. So there was a question last class where we found that the answer was 3.71, not 3.73. There was a small gap out there. The gap is because of this purpose. It's just one mark though, but it is what it is. So if you literally go to the North Pole, right, you're not actually at this rotating point of axis. The axis is tilted by 23.5 degrees, I think. So it means that you have to be slightly off. Slightly? So that's the place where the weighing machine will show your true weight. Gravitational potential graph হচ্ছে যেটা, this one and this only, আর কোনো graph possible না, because gravitational potential তো সবসময় same. Electric potential এর graph হচ্ছে এই চারটাই হয়. So think of this as the potential energy that you have, right? তুমি যখন দূরে, your potential energy is the greatest. আচ্ছা, কেন greatest? কারণ হচ্ছে greatest মানে in the sense that যত দূরে যাচ্ছ এটা আস্তে আস্তে কিসের কাছে চলে যাচ্ছে? জিরোর কাছে. right? So if you stretch this line all the way to infinite, where would this line go and meet? At 0. So at infinity, you have your potential to be 0. As you're moving towards the surface of the planet, right? Potential value দেখো কমতেছে, এদিকে নিচে নেমে যাচ্ছে না. I know the value itself is increasing, but it's a negative value that's increasing, right? So you're actually losing energy. So এই পয়েন্টগুলো সব represent করে how much energy is being lost as you're moving towards the earth. So let's say if you go from this distance to that distance, you lose this much potential in the process, and that much potential energy as well, and that becomes a what? K. And the closer you get, you'll notice the graph steepness বেড়ে যাচ্ছে. And that's kind of obvious because the closer you get to a planet, right, the gravitational field strength is stronger. So you're losing more energy per unit distance because work done is forced into distance. So more force has been exerted on you. Dure changes গুলো খুব subtle হয়. The gravitational field change is very small due to the inverse square ratio. Oh, it's the other side of the planet. Right? তুমি একটা প্ল্যানেটকে দেখো লেফট আর রাইট আছে না, লেফট সাইডটা রাইট সাইডটা, আর এদিকে গ্রাফ যেটা হয় এটা হচ্ছে ইলেকট্রিক ফিল্ডে খালি পসিবল, যে তুমি একটা প্ল্যানেটের কাছে আসতেছো আর তোমার হচ্ছে কি বেড়ে যাচ্ছে, পোটেনশিয়াল বেড়ে যাচ্ছে. This can only happen if the forces are what? It can only happen when the forces are of what type? That you come closer to a mass, your potential increases, not decreases. Yes, repulsion. Okay, so এই গ্রাফগুলো হচ্ছে সব রিপালশন কেসেস এ হয়. সো একটা প্লাস এন্ড প্লাস এর গ্রাফ এরকম দেখতে হবে, একটা মাইনাস মাইনাস এর গ্রাফ এরকম দেখতে হবে, বাট একটা প্লাস মাইনাস এর গ্রাফ এরকম দেখতে হবে, একটা মাইনাস প্লাস এর গ্রাফ এরকম দেখতে হবে. Yeah, because it's a good question, but we can't really reach the center of a planet. So taking that point is a complicated process, number one. Number two is that not every planet has the same shape and size. So therefore, these values can vary. But this is same for everything out there. So it's a good reference point. আচ্ছা 9B তে যেতে বলছে. 9B তে apparently there's a graph যেটাতে প্রবলেম আছে, দেখি. Your class clashes with this. When does your class start? 2:30. Oh, এটা আমি ফিক্স করছি. I can start at 2. So do you 15 minutes ম্যানেজ করতে পারো? মানে আমি এটা কি 2 থেকে নিয়ে আসতে পারবো? I have another slot, but ওই slotটা মানে জিনিসটা কি, I can't give a time that's favorable for everyone. It's impossible. সবার একটা না একটা টাইম থাকবে. So if we can plus minus this time, best হয়. But I have other times that, for example, হচ্ছে এখন একটা বলবো, I'm pretty sure one of you will say না আমার তখন ঘুম আসে, তো কিছু একটা. That's what literally everyone says. Other batches they'll go like, না স্যার ওই টাইমে আমি পড়তে পারবো না, আমার মাথা ব্যথা করে. That's the excuse that I got for 4:30. হ্যাঁ, আবার হচ্ছে ইফতারের পরে হচ্ছে প্যারেন্টস বাসাতে বাড়িতে দিবে না, সেফ না, এরকম করে করে ইভেন্টুয়ালি কারোকে আমি স্যাটিসফাই করতে পারবো না. সো 15 মিনিটস যদি ম্যানেজ করা যায়, আই থিংক ইটস ইজিয়ার. ওকে, বাট দ্য আদার টাইম স্লট একটা প্রবলেম হচ্ছে উইথ দি আদার ব্যাচ, ওদের কিছু ইস্যু. সো ইটস 3:45 to 4:30, বাট আদার ডেজ সানডে, টিউসডে, থার্সডে, রাইট. আর একটা হচ্ছে যে 2 থেকে 2:45 আজকে, লাইক দ্যাট, অর হচ্ছে আজকে 1:45. আচ্ছা দেখতে হবে, 1:45 থেকে 2:30. না, ওটা থেকে সানডে, টিউসডে, থার্সডে পসিবল হবে. সানডে, টিউসডে, থার্সডে 1:45 থেকে পারবা? আর 4:30 to 5:15 এই দিনগুলোতে, 4:30 to 5:15 স্যাটারডে. হ্যাঁ হ্যাঁ, আচ্ছা. সো এটা this other batch, ওদেরকে বলবো ওরা যদি এগ্রি করে যে ওরা ওই টাইমে ওদের কিছু ইস্যু আছে, যদি ওরা এগ্রি করে then I can do that. But for the time being, let's think of the worst case scenario. ওরা যদি এগ্রি না করে তাহলে এটাকে আমি হচ্ছে I'll try 145 but 2 definitely পারবো. Okay, so 2 থেকে স্টার্ট করে same days. Right, so এখানে question দেখি define gravitational potential. We have seen this. এটা একটু দেখো, it's a graph. Let's see how does the graph look like. So এখানে বলছেন isolated solid sphere of radius r may be assumed to have a mass concentrated at the center. The magnitude of the gravitational potential from the surface at the surface of the sphere is phi. That's a minus 5 বলেন নাই. On figure 1.1, show the variation of gravitational potential from a distance of d from the center of the sphere for values for dr to d eta. So আমাদের বের করতে হবে হচ্ছে এখান থেকে গ্রাফটা distance of d, মানে you can't go inside the planet, right? So surface থেকে start করতে হবে, and ওরা বলছে this part is important, the magnitude of the magnitude বলছে of the gravitational potential at the surface of the sphere is phi. So if the magnitude is phi, should the value be phi or should it be minus phi? Negative phi. এটা কিন্তু হচ্ছে important. So it must start from here. And ওরা বলছে you're going to 4r. When these are like 3-mark graphs, right, you need to have exact value out there. It follows what relationship? Inverse, not inverse square. It's a phi, right? Phi equals to what? Gm by r or d. So এখানে হচ্ছে যদি তোমার distance 4 times বাড়ে তাহলে phi will decrease by 4 times. তাহলে কত phi হবে? 0.25 phi, right? So it should be there. আর 2 তে কত হবে? Half. আর এখানে 3 so এটা করে তোমাদের একটা লাইন কানেক্ট করতে হবে that goes to these points out there. They're usually very strict about the plots, মানে you have to be careful. So something like that. Now এটা কি সারফেসে বাড়ি খাওয়ার কথা? হ্যাঁ, ঠিক আছে. So it should be like that, the graph. আমি তাও একটু চেক করে দেখি the mark distribution. হ্যাঁ, বলো. The negative highest. It means it has lost the most amount of energy at that point. And the gradient is the steepest because the gradient gives you a gravitational field strength. Gravitational field strength is the highest at the surface. May, June 24 to actually. So their marks go that distribution. It says that a curve from r to 4r with the gradient decreasing in magnitude, starting at r with plus minus phi. Okay, they allowed plus phi as well, and I believe they allowed plus phi here is because negative throughout. I think হচ্ছে যে ওরা phi যেহেতু বলছে, it could confuse students because just magnitude কথা বলছে, but yeah, we know it should be negative. Passing through, this is the part that's important, 0.5 and 0.25. And a 0.5 and 0.25 দেখাতে হবে, and showing the negative potential throughout. মানে তোমার গ্রেডিয়েন্টটা হচ্ছে negative line showing negative potential. Line showing potential is negative throughout. আচ্ছা, so তোমার যদি negative potential না করে এটা করতে, you get 2 out of 3. এটা করার জন্য you get full 3 out of 3. The third mark is for showing that all the potential values are negative. Okay. Right, তারপর বলো কোনটাতে problem? You have to solve these questions and ask me problems, otherwise so it'll be difficult. Did you guys do question number 13? 10? No, it is the last class বলছিলাম, তারপরে তো বলছিলাম বাকিগুলো করতে. 9CI, আচ্ছা দেখি 9CI কি ছিল? It says a sphere B is a planet of radius 6.4 into 10 to the power 6 meters, and mass M, which is 6 into 10 to the power 24 kilograms, and no atmosphere. A rock of mass moves directly towards the planet. Its distance from the center changes from 3r to 4r. So 4r chilo, এটা 3r আসে. That's the variation. Calculate the change in gravitational potential of the rock. Calculate the change in gravitational potential of the rock. So phi equals to minus gm by r. This is phi 1. Phi 2 is equal to minus gm by r again. আমাদের কোন r হবে 3r and 4r. Right, so just find the difference. Direct again. এটা কি সারফেস থেকে r দেওয়া? Distance from the center of the planet changes from 3r to r. আচ্ছা আমি চিন্তা করে দেখি দাঁড়া এখানে ওরা কি বলছিল what is r? D is r. So প্ল্যানেটটা এরকম দেখতে, প্ল্যানেটের সারফেসটা হচ্ছে d and this is r. এখানে হচ্ছে how do you do this math in one step? Change যেহেতু যাচ্ছে, change in phi equals to keep বাইরে কমন নিবা gm আর মাঝখানে ব্র্যাকেটের মধ্যে 1/3r minus 1/4r. এখানে সাইনটাকে ইগনোর করবো, আর সাইনটা যদি বাইরে নিতে চাও তাহলে 1/4r minus 1/3r, মানে সেম জিনিসই আসবে। এখানে হচ্ছে r এর ভ্যালু কি দাও আমাদের 1/4 minus 1/3. Won't change our answer, but to change the overall change